the solar car team, as you can see this in this photo right here. My name is Toney. I am the lead of the strategy CS part of the team.
I'm Chris Heinz, engineering manager, former mechanical.
So he's in charge of all of us. So we're just going to give you a brief update about the solar car team, because we presented actually the peak and current last semester, so it's more or less going to be expanding off of that. So first, this is more or less how we're going to go through this presentation. First, we're going to talk about the team and then the race. And then Chris is going to talk about the conference a little bit and some Capstone projects. I'm going to talk about my senior design project and then where the team's going to be going on for 2017. So, as you can probably guess, our main objective is to design, build, and race solar cars. We have a race every single summer, and it alternates depending on the year, but that happens every summer. Right now, we're actually in the process of designing our next car. And there's a lot of really cool network subsystems as far as CS goes. It's actually related to senior design projects that we're trying to get together for the next car. The team was founded in 1999. Approximately 17 years. It wasn't quite at the end of 1990. But right now we're on our 5th car, I believe. Gato del Sol 5. So then they did not have fun. We are independent and student-led. So it's all just students who are trying to solve these large engineering problems. It's mechanical, electrical, computer science, a lot of different problems. We do have 2 advisors, which are Dr. Henninger and Dr. Ashley, who advise mechanical and electrical parts of the team mainly, as well as helping us make large business decisions and what we're going to spend our money on. Sorry if my voice is somewhat hoarse. I'm kind of feeling under the weather right now, so I apologize for that. But we actually are a pretty large team. As you can tell from the photo, there's actually a few more people on the team that just weren't able to make it to the meeting. But we have a very diverse team. We have some business majors as well as computer science. Whenever I joined the team, actually, there wasn't any computer scientists on the team. So we kind of had to start back up the strategy part of the team. But in the past, there had been CS leads for the entire team. So it's just kind of off and on who's really on the team. And our current car, like I said, is Gato del Sol 5. It was completed in 2014 at the race, I believe. Yes. With interesting success. More about the car. The car weighs 800 pounds, and we've gotten it up to 73 miles an hour before, which I believe you were in the car.
I was in the car for that.
I would never drive it that fast, just because I know we built it. But he played ahead in a large portion of it, so I guess you were trusting yourself.
I trust him.
On solar power alone, we can go around 27 miles an hour, give or take, depending on road conditions as well as how much cloud coverage there is, and if the battery pack decides to be temperamental that day or not. If we're running just on the battery pack alone, we can go between 100 and 150 miles. That also depends greatly on the things I just mentioned. More things about the car. It has a very interesting system on it right now to collect data from all the different parts of the car. It's actually a USB system, which I talked about last time, but I'm just going to briefly talk about it. To where we have a Raspberry Pi on the car that connects to USB to all the different devices in the car. And based off of the hardware ID on the chip that are in each device, it figures out which device it is and then proceeds to process it, parse it, store it in a database, and then proceed to send that over a radio connection to a trail car. We do a lot of our more computationally heavy things like computing the state of charge of the battery pack and things like that. So next on, we're to the race.
Could you give us some idea about the constraints where it goes? We are given? Because I'm sure building a very smaller car perhaps would be possible, but there is some lower weight limit, or I don't know.
Sure, yeah. So the main constraints we have are for this car, we were only allowed 6 square meters of solar array, and there were a particular set of cells that we were allowed to choose from. Cells that are too efficient, they would actually reduce your allowable area. We're also limited in terms of, there's a maximum battery pack weight, which works out to about 5 kilowatt hours, and the weight changes depending on which chemistry. So if you have a heavier chemistry like lead acid, you can have a ton of batteries. If you have a light lithium-ion pack like we have, you can only have 20 kilograms. Aside from that, there are various structural rules, just in terms of crash safety, and then there are practical limits of like you have to fit the driver in the car. They've got to be able to sit there for 3 to 6 hours.
There has to be a driver.
There has to be a driver, yes. There are handling requirements as well. One of the interesting things is a lot of these like design objectives are at odds, right? So if we just wanted a really aerodynamic car, the car would be a lot smaller. But we also want a large solar array that's relatively flat. And so sort of when you combine those, the optimal case ends up being pretty close to like a wing with some bubbles, which is what we have and what basically all teams have. There is a maximum size, but most teams operate below that just because, the more size you have, the more weight, and then the more aerodynamic drag as well. So those are our principal constraints.
And what is it made of?
It's made of carbon fiber. So there's a carbon fiber body, and then inside there is an aluminum tube chassis.
So the main race that we race the car in is called Formula Sun Grand Prix. This one happens every year at differing locations depending on the year. This year we're going to be in Texas, Dallas, Texas? Austin, Texas, at
Circuit of the Americas.
yeah, Circuit of the Americas to race the car there. It's a really nice facility actually. Last summer we were in Ohio racing.
I was just wondering, you mentioned it's in Texas this year. Does it move around between north and south, or is it always kind of south to like more sunlight?
Well, actually, in the summer, more sunlight in the north.
So last year it was actually in Ohio.
Yeah, it was in Pittsburgh, Pennsylvania. But they did that because they wanted the track race to be near the beginning of the cross-country race, and they do change that route every year. That's actually like the next slide. So.
But yeah, so for this competition, it's really just an endurance race. So everyone puts their cars in the order in which you finish through a scrutineering, which is whenever they review your car to make sure it meets all the regulations that we just talked about. It's pretty strenuous. Some cars don't even get it on the track when they go in this race. And it's you have 3 days and a lot amount of charging time each day, and you just see who can go most laps given those 3 days, and that's how they determine them. So this year, this past year in 2016, we actually finished 4th as far as scrutineering goes. So our car was very quickly given the green light to go into the track. We completed 97 laps, which was roughly 155 miles. And we had a massive engineering hurdle to overcome. While we were driving the car during those 97 laps, the battery ripped itself apart, for lack of a better term. Our battery pack was too rigid, and the vibrating of us driving the car was tearing it apart. So we had to go in and completely rebuild the thing and change how the cells were connected to each other so they could move around a little bit more. I was told that was a nightmare. I'm not electrical, so I don't.
It took about 36 hours of the entire team working to tear it all apart in a hotel room, put it back together, and then get it re-inspected back into the race.
Duct tape?
I don't think any duct tape was used. Certainly zip ties. Certainly a lot of electrical tape. It's a hot glue.
Yeah, so luckily we were actually able to recover from that battery pack failure. And due to the fact that we got all these laps in, the battery pack failed, and we seemed to be a promising team, the officials actually let us go on to the second part of the race, which is the cross-country part of the race, which is America Solar Challenge. And this is where all the teams who pass the FSGP number of laps, or the officials think you can, you start in one state and drive across the country. Changes every time it happens. This is every 2 years. This last year, it was going through a lot of the national forests in the United States, so very scenic. We did not make it through the entire race, sadly, but it was our first time competing in ASC since 2010. Due to many different engineering failures or the car not being completed by the time it was to be at the race. So that was a big accomplishment. We were able to actually qualify to go on ASC, and we did complete 136 miles until more failures happened. We want to talk about some of the things that happened.
Yeah. Sure. So on the first day of ASC, we actually had to drive through a large number of very heavy rainstorms. And as a result, the sensors inside our, this is our theory, we haven't fully root caused it, but this is the best we can come up with, is that the sensors inside our motor that enable it to run got wet, and then we're not providing meaningful signals to the controller. And so we had to stop basically and wait for it to dry. We were looking for problems. We didn't know that was the problem at the time, but eventually it started working again, and we were able to continue. But since we had only provisionally qualified, since we didn't officially make the required number of laps due to our earlier failure, we did not make it to the checkpoint in time, and so we were then moved from the race.
So I guess now we're on to the conference.
Yes, so now as to the conference, so this is the International Education Foundation. It's the nonprofit that runs our races. They threw a conference in this past February. I think it was February. They also threw one in 2015, and we attended that. That was the first one in a while. We found it really beneficial, so we wanted to send new members to that this time. So it was a 3-day event, basically where we just got together with the officials and other teams and talked about solar cars, talked about the races and the regulations. So that first night was basically we read through almost like chapter by chapter the new regulations. Teams asked questions, officials answered unofficially, and sort of came up with a few areas they need to refine more officially. Then the next day was basically an 8 to 6 kind of day, where we had basically instructional sessions from the advisors and alum of teams as to like what are some best practices when designing a car. And so they would split the teams up into the various subsystems. So there was mechanical, electrical, sometimes a strategy CS, and then logistics. And they would go learn about like this is how you design the car mechanically. These are some good ideas. These are some bad ideas. These are the things that people have done and failed. So there's a lot of like proof by bad example on that. And then while all that was going on, we also were able to schedule some one-on-one sessions with the inspectors, where we could literally just have them to ourselves and ask questions either about design or regulations or just what do you think of this design that we've come up with so far? And so we found that to be really helpful. There was also a lot of networking between teams. There was some downtime, so we would eat lunch with each other, eat dinner with each other, and so forth. There were actually dedicated networking breakout sessions with different interests, so management, people who are going to be graduating soon, and so we were able to talk to them and figure out what they do a lot on the management side as well as the technical side. So how they manage their projects, how they deal with retaining knowledge as an institution, even though they have this like 100% 4-year turnover rate from people graduating. So that was really helpful as well. They're going to be sending out some various surveys of teams that want information about how other teams run. Basically, they're collecting questions, and then they'll send out the survey, collect answers, and then publish the answers. So that'll be good to learn from our other teams. And then there was a lot of emphasis on project management. Obviously, we need to start meeting our deadlines. Don't show up to the race with the car half built. We're not the only university that does that, by the way. A large number, including like MIT, Georgia Tech, have showed up with, this is our car, it doesn't have solar cells on it, we're painting it tonight. And so that ends poorly for everyone. But they really focused on, how do you manage that? How do you motivate a group of basically all volunteers, right? We're not paid, so we can't be like, well, I'll fire you if you don't do this, because they'll say, all right, see ya. And so the motivating factors and sort of the management aspect is a little bit unique and more difficult in that regard. So our takeaways from the conference as a team are a much better understanding of the regulations. So through all those things, we were able to discuss and come up with, basically teams were asking about the edge cases of the regulations, and we got some level of clarification. So now we understand sort of what our constraints are when we're going to be building this car. Our new members that attended also got to learn a lot about the best practices, see some photos of failures of other teams, the results being battery fires or cars with their wheels flying off, and then discuss like the actual root cause of that is like, well, if you use certain materials and you make bad assumptions about them, then your spindle's going to break and your wheel's going to fly off. We also sort of, as an organization, got a wake-up call in terms of the importance of the management and planning side. So basically a week after this, we sat down the leadership sat down, and we came up with our timeline, our renewed timeline for this car, and we sort of told the rest of the university that, or the rest of the team that, you know, if we keep going like we are, sort of casually doing this, we're going to have a very hard time to have a car come 2018. Yes?
So I have a couple questions on this.
Sure.
So the first question is, do you have sort of a succession plan? I mean, do you have, you're the Grand Poobah, but is there a Grand Poobah elect who's going to take over after you? That's question one. And question two is, how do you capture your corporate memory and sort of make sure that you pass on to the next crew the lessons learned, the best practices, but also the lessons learned so that you don't repeat the same mistakes?
Sure. So far, our Grand Poobah elect has been convinced me to get my PhD. But after that, we did really, this was a good wake-up call for like knowing that we need to like have a plan for that, right? And so the intent is going to be, some teams talked about as well, is they'll have a spring election cycle. Instead of changing leadership right after the race when they're getting new members, they'll change leadership in the spring. And so there's that whole semester of overlap where like, I'm no longer in charge, but I'm still there to help the new person, you know, figure out what they're doing. And then all leadership offices sort of have that, and then people can still work their way up before they graduate. So we do intend to do that. As to the documentation and making sure we don't lose that knowledge, we're going to be making a bigger effort to put some written documentation to place, like as we're designing something, you know, not even too formally, just like this was my intent when I designed this. And then if we do have a subsystem failure, afterwards we'll go through and we'll do basically a post-mortem and say, this is what broke, this is why we think it broke, and this is what we recommend going forward. And we're going to be doing that with events similarly. So, you know, 2014, 2015, 2016, we're going to write up basically reports of like, this is what happened at the race, these are the problems we ran into, this is what we recommend to address it. So that's on the succession side, and that is a huge challenge with this much turnover. Missouri S&T actually, they were given an ultimatum by their university, like, get better or we're going to cut your funding, because they had that break in their continuity. And we had a similar break after Goddard sold 4. So when we were building Goddard 5, it was basically from scratch. And as a result, we made a lot of mistakes, some of which we've been able to fix, and some of which are just, you know, the design is not sufficiently optimal. So the best practices, focus on management. There was also a lot of talk about the importance of strategy and modeling. The University of Michigan does a great job with this, and basically 2016, the American Solar Challenge was plagued with a lot of rain and unpredictable weather. Well, they were able to predict the weather, and as a result, they were able to make decisions to like drive faster to outrun the storm. Like, yes, we know this is not what we would do if it was going to be sunny here in the next 4 hours, but since it's going to be raining, we want to get ahead of this. And as a result, they were able to finish the race 11 hours ahead of everyone else. So that's sort of given us a further wake-up call on the importance of the modeling and simulation side, both for race operations and deciding where we want to focus our design effort. So, you know, is it worth 10% more weight to have 10% less drag? That sort of a decision is be great to be able to make quantitatively. So that I sort of basically just talked about the slide. Our action plan is that we're going to be making a parametric model of our car for the 2017 race from a strategy perspective. We're going to expand that for 2018 with our new car. Leadership meeting on current culture and long-term goals. Again, that's just making sure our team doesn't like stagnate, and we don't stop making progress. And then finally, like I talked about earlier, more emphasis on timelines, deadlines, and testing. One of the things another team said is that, you know, build time into your schedule for redesigns of components. We've, as an organization, sort of not done that just because of the cost and the time. It's like, well, I'm designing the suspension for this car. It's not like we get a Rev 2. But in practice, right, that Rev 2 could be very, very valuable and could be worth the money and time. And so build time into the schedule to allow for that. I guess I'll go on and talk a little bit more about our Capstone projects. I sponsored 3 Capstone projects with them so far. The first was a dynamometer for the mechanical team, or the mechanical department. And basically this is a load that we can use to load our motor mechanically. It's a big flywheel and lets us store the energy of the motor up, and then we can use the regenerative braking to get that out. And by knowing basically effectively the mass, the moment of inertia of the flywheel, we can quantitatively know this is how efficient our motor is when we operate it in this way. So not only does it allow us to sort of shake down and test stuff at full power without the car moving, It also lets us quantitatively evaluate the efficiency. The variable motor efficiency, as a function of, how hard you're pushing on the throttle pedal really affects like the micro strategy of races. So like, how do we want to go over this hill? Do we want to speed up at the bottom of the hill and then slow down as we go up it? Similarly, if we're at the speed we want to be going and we're about to go down a hill, should we use that regenerative brake even though it's only, say, 60% efficient to keep our aerodynamic losses down by going the same speed we want to go to? Is that worth it? And so understanding the characteristics of our motor is very important for that. And then this is probably one of the only successful prototypes that came out of that year's set of programs. It's fully functional, it works. We've had this thing up to full speed, storing basically the amount of energy the car has going 70 miles an hour in this flywheel, and it works. Whereas a lot of the projects they end up being scale models or, sort of designs that are never fully implemented.
Is this a mechanical engineering?
This is a mechanical engineering capstone project, yes. But this is sort of how we branch out with our subsystems that are far enough removed, far enough abstracted from the car that we can sort of compartmentalize it and give it to someone. The other one is in its second semester now as the brake system. So they're designing for us new brake calipers that will use springs to actively retract the pads to keep any rubbing from occurring. This has been a big issue that a lot of teams have had, is if your brakes are rubbing, you're just burning energy. And on a car, it's not really a big deal because you have a big gasoline engine, but on a solar car, right, this could be, 10% of your power is going to just warming up your brakes by this rubbing action. And so they're on track, they're ahead of the schedule for the class, and they're going to be testing next week on that dynamometer. We're going to try to slow it down with their brake, and, that way it's a nice, safe, static test. Where they don't have to put their brakes on the car and then drive it up to speed and see if it works. Finally, we're working now with the Spark Lab over in electrical for some postdoctoral research on motors and power electronics. And so they're trying to develop a new motor for us it's like a semi-coreless topology. So motors in general, either they have iron cores in the coils or they don't. This is sort of an in-between topology, and apparently offers advantages in terms of cooling and weight and efficiency. And so their main goal is to give us more efficiency at higher torques so that we can have more control over our speed and we can more aggressively, say, climb hills at a constant speed or not get stuck on hills when we have to stop on them and then we have to push the car and incur penalties. They're also going to be working on the power electronics for that. Basically, we have a DC battery pack, we have an AC motor, so we need to convert that DC into a three-phase sine wave that's in phase with the rotation of the motor to get it to actually work.
So, Fish, penalties. So does
Sure.
that mean that you maybe actually drove more than 193 miles last year, but they penalized you miles?
They did penalize us some miles. There are various reasons for penalties, either pushing or doing things like recharging your battery packs and not using solar energy, which we are considered to have done because for that 36-hour period, we had the batteries out of impound. They make us lock them up overnight. But there are also technical penalties, like in 2016, we could not make a parking brake that was to their satisfaction. And so that was like a 1 lap per day penalty that we incurred. So that just sort of encourages compliance with the regulations, but doesn't fully remove people who, they built their car and, oh gosh, all we have is this parking brake and now we can't race because of it. And it's really not that important per se. It's not like a safety issue, right? So if you can't meet the safety requirements, then you just can't race. And finally, I'll turn it back over to Ethan to talk about his senior design project now in CS.
As a slight side note, the parking brake has been the bane of our team for the past 2 years.
4, 5, back to 2012 probably.
All I know is we have a bucket that just has the remains of our past attempts at parking brakes. So one of these years we'll get one. So I'm going to be talking about the CS senior design project that's related to the car, and it is a guitar force parameter estimation, as you can see. It's a little bit more than that. First, explain this graph. That's actually data we currently have in the car. I just pulled it off the car Saturday, and it's just the graph of the voltage over time plus driving the car. And you can tell it's not very good because, you might be able to tell that, our battery pack is not very evenly balanced right now. There are a few cells that are very low and a few cells that are very high voltage, which is bad because the battery pack turns off the second one of them is too low. So
Or too high.
yeah, or too high. So the goal of this CS Unit Design project is to take all these different systems like the battery and the motor and all these other things that Kyra is talking about and read all their information and apply it through a common filter so that we can get more accurate data from all these different parameters, and then try to guess when the car is about to have a problem or what the problem would be. So for example, in a graph like this, let's say one of those lines was going, it was decreasing faster than it should. That means we probably have a cell in the pack that either has a short across it or there's something that's causing problems, so we should stop the car, open up the battery pack, and see what's going on. So that's kind of what the goal of this unit design project is just to get more information to help us debug problems faster. Here's our funny award for breaking the speed limit on the track 1 year. So it was 2015. We were having more or less the car was not doing great. We realized we had enough juice left to just gun it and try to break the speed limit. And one of the officials told us that if we did, he'd give us a trophy. So, I mean, we were going for the trophy, so there it is. We didn't officially get the fastest lap because we almost hit another car, but we did get the fastest instantaneous speed, so got that going for us. So our goals for 2018 are to get first through scrutineering, top 50%, and then there's a most improved award, which we're also aiming to get. And normally our electrical subsystems are really they're designed very well, so we're also going for the electrical design award. I'm just zooming through this because I want to have some time for questions. So, and hopefully at some point our car will be good enough to go on the large race that you see here across Australia, which is where teams like Michigan and I don't know.
Delft University from the Netherlands, Principia College, it's actually with a lot of Chris College, they go there as well. Stanford goes there. I'm trying to think of other big names from the US.
But yeah, so that's the World Solar Car Challenge. So that's where everyone wants to go, but our car does not meet their regulations right now. Because they have a slightly different set of regulations than FSGB and ASC, so you kind of have to have a car that's built for both, which right now the regulations are getting closer, so maybe we'll see that in the future. And here are some of the things that are going to be changing about the next car. It's going to be 4 wheels, have a brand new solar car. There's going to be a brand new solar car, but a new solar array, a brand new electrical architecture, which is similar to the CS design project. We're going to monitor everything on a peer-to-peer network, and a new motor and a new frame as opposed to the current one. That's it. Any questions?
What do you do with the old car when you build a new one?
It's a great question. So Gato del Sol 3 is actually in the Kentucky Science Center on display, and we are actually looking for a place to put Gato del Sol 4. Right now it's in our trailer. There was some stuff with a high school that actually was going to try to upgrade it and then race it. There's a high school level solar car where basically what they do is they get universities' old cars and then they rebuild them and put all the components that we took out of them back in, and then they race them. So we were going to do that. They sort of dropped out. We welcome any ideas that you might have.
Living Arts and Sciences Center.
The new Arts and Sciences Center?
Living Arts and Sciences Center here in Richmond.
Really? I'll have a business team give them a shout.
Okay, so,
Sorry.
How do you determine when to build a new car? Because you mentioned that it started in 1999, but you said that your most recent car is got an Sol 4, so how can you replace the car?
So we're hoping to get onto a 2-year build cycle for a number of reasons. First, obviously, it's good to continuously improve, and as tightly coupled as all the systems are, it's really hard to just replace one thing. Obviously, electrical systems, it's a little easier, but you can imagine if you want to do suspension, you might want it to attach to the chassis in a new way. But also, we want the 2-year cycle, because that's when the new regulations come out, is on a 2-year cycle. Usually, they're close enough that you can sort of modify to meet the next set. And finally, we want basically people to be able to be on our team as undergraduates and learn a whole lot, and then as upperclassmen, be able to build the car. And so that'll really help a lot with our continuity there.
Well, we're out of time. It's great that there's so many questions. Hopefully you'll be around afterwards and we can ask you more questions then. Thank you very much.
Thank you.